let me start, and I just want to say thank you everyone for joining our webinar today. We had a bit of questions around how New Vector works, how SUSE Security works, what Zero Trust is, and we thought it's going to be useful for the community to hear out what our thoughts are beyond just the standard presentation of the product, and how we think it should work, and how the security in Kubernetes should be addressed, considering all of these zero-day threats and things like that. And also, we think we needed to differentiate between what we know about the threats and how we solve these problems, and versus how we solve problems with unknown stuff that's trying to attack the cluster. So all these things I'm going to quickly recap in a very short deck, but then I'll jump into a live demo, and you will have opportunity to ask questions as we go. And I'll have a few people who are from SUSE who are going to help me answer those. And if there is anything remaining we won't be able to answer it, we'll follow up with email or potentially another session to address all these questions. With all that, let me quickly jump into, as I promised, a really short deck, about 10 informative slides. And let me know once you see the screen.
Yep.
Oh, good. Fantastic. Thanks a lot. So the theme of today is protecting workloads from the unknown. And let's start from the very beginning, where this unknown comes from in Kubernetes environments and why it's actually it's even a problem. So security is slightly different for Kubernetes, and the reason for that is pretty simple. Security in Kubernetes is covered through non-standard ways as comparing to our data center. Traditional data center equipment, as you see on the right, has a variety of already well-known tools that help you. Web application firewalls, firewalls of general nature, perimeter security, things like that. They work pretty well, and they work pretty well for the environment where you have a pretty static configurations and pretty static set of assets that you protect. Kubernetes on the left side is a whole different world. The problem of workloads coming and going, hidden layers of networking, and the lack of any secure default, that basically creates a problem for Kubernetes. The key reason why Kubernetes has never been designed to think of a secure environment as by design. It was designed to be able to develop things quickly, and it is really convenient when you don't have security to think about. So that's why you don't have things like network policies by default. And it was built around things that simplify things. So that's why you have virtualized networking. Other than that, obviously, if you take a standard data center tool and try to build a firewall inside Kubernetes, it doesn't really quite work, because by the time you create a policy for any workload, it's probably already gone, and this pod is destroyed and another pod is created. So it doesn't really work at that scale. So additionally to that, there are new things called attack vectors. So because of new things that Kubernetes brings in, so like images, supply chain that comprise a lot of open source projects and not open source projects. It comprise of all of these third-party dependencies that you use to build your containers themselves, and also things like pod-to-pod communications that's never been dealt with in the physical world. So all these ephemeral things aligned with new attack vectors have a significant problem for traditional security tools. And this is why we see it as an additional problem, and totally different to what we see in the standard data center environment. So we thought of this puzzle as it has to have the way to address it. And the way they think about it is is defense in depth. And when we're thinking about defense in depth, whatever you see on the right-hand side in the top, the supply chain security bit, it's usually pretty well covered. And if it's not well covered in your environment, I literally beg you, just go and cover it. Because today there are a number of open source projects, or open source security scanners, or even our own SUSE security scanner, if you like one, can address problems of supply chain security that help you understanding what existing threats are entering your cluster and how you block them and how you deal with them. So filtering out existing threats is probably the first step you take on that journey. We probably think of this being pretty much a solved problem, although a lot of customers will understand they on a very different speed in that journey, and we encourage to look at supply chain security first when you're dealing with security in Kubernetes. But today's topic is more about things like runtime security, that in the bottom right. So runtime security is something that deals with a problem where we don't have exact knowledge of the problem. Think of zero-day attacks. Think of malware that doesn't have a current signature, or it spreads through supply chain and it hasn't been detected yet. It didn't go into any of the known CV databases, so it cannot be filtered out. So it can enter your supply chain and create a security problem for the cluster. So how would you deal with that? So this is where we think the last point in defense in depth approach is going to be zero trust runtime. So we spoke about zero trust, and everyone in security market literally try to sell zero trust. And this is where I think we need to define what we think about zero trust in Kubernetes and how it should look like. And this is where I think we have our own vision around zero trust. And I want to stress that SUSE version of it. And the zero trust in SUSE edition it's a policy that sits in Kubernetes, and it defines everything that app needs to do in order to function. This defines processes it needs to create, networking communications layer 3, layer 7 processes it executes, and additionally files it creates, and pretty much denies everything else, which is a way to express an enclave where you run something and it only runs the stuff that it needs to run in order to function. If we add on top of it that this policy should be declaratively defined and enforced, then you may end up with well, that's a pretty cool thing, but that's a big ask, because to define a policy for every app that you have, and you may have, like pretty much everyone, hundreds or thousands of microservices running in a cluster, it's kind of a difficult task. That's why we think this also policy should be derived from application behavior, and it should be created automatically. This is quite a big ask, and you may raise a question. So how that actually happens? And we had a few conversations with some of you, and a lot of people refer to it as like, yeah, it's a bit of, sounds a bit like magic. So I'm going to show you today that it's not really difficult. I mean, it's doable, but I mean, for some vendors it may be difficult, and some, but that's why we have this beauty of open source, where everyone can see whoever is what they're doing, and just enhance their projects as well. So we have a product and open source projects called NewVector, and I'll quickly go through it, what it does. It also has a name of SUSE Security if you decide to buy a subscription from us, but it doesn't really need to be SUSE Security flavor of it. It can be just github.com/NewVector. And this product has been very important for us to strengthen Kubernetes security offering. So NewVector was a company that produced a proprietary product called NewVector. We acquired it in 2021, and we open sourced it, because whatever SUSE does is open source. You don't actually buy products from us as such. And NewVector as a product has a fair bit of patents attached to it, about 10 of them, about how it does things. And I think last time I saw that we donated those patents to CNCF. So essentially, it's a free to use product, and you can just go and install it yourself. But what important about this product is built cloud native and very lean product to do exactly what it's supposed to do in Kubernetes native world. For that reason, unlike many of the security products for Kubernetes you see around, NewVector doesn't use agents that install inside your container. It doesn't use sidecars. It doesn't use proxies. It doesn't use IP tables code injection or node modification that traditional security tooling would do to your cluster. And it actually runs all of your workloads unmodified in any shape, but literally in any shape or form. It doesn't even need to use eBPF if you don't want to. It could be useful, but it doesn't use it for security enforcement because eBPF tables in kernels can be quickly overflown by targeted attacks, so they hardly suitable for security as such. For observability, maybe. And it's a very lean product if you look at the architecture of this tool. It's got just one pod per node in your cluster for enforcement, one replica set with 3 replicas by default for controller, for its brain and REST API, one pod for web UI, and the dynamic number of scanners that come and go to scan for existing vulnerabilities. It's very efficient and very lean tool. This is why I wanted to stress that it's totally cloud native and it doesn't need significant additional resources to run, unlike traditional security tooling. So what's cool about NewVector and how it actually started and how it does things? It actually has deep packet inspection built in the very core of it. And this product sits on top of Kubernetes virtual switch, unlike pretty much majority of other Kubernetes security products that sit on in eBPF. So for that reason, deep packet inspection that sits on the switch can actually see much more communication information than it's allowed by kernel. And for things like node to node and pod to pod communication is very important. And unlike eBPF tooling, it can do things like layer 7. So it can detect things like SSH tunnel over DNS port and things like that. So plus it monitors all the processes that your workloads run. So with that, it actually can do active things. For example, it can block certain communications because it sits on the switch, and it can do it out of the band. So it doesn't need to sit inside that communication to prevent it from happening. So it's not like a firewall that sits inside the container. It can just prevent things from happening without causing too much delay to the traffic. And additionally, DPI obviously enables a set of goodies if it's used properly. So it uses automated behavior learning, so it actually knows what application is doing. So it knows what processes it creates, what files it creates, what network communication it creates and receives, things like that. So it can then record all of this and puts this into baseline profile that you can use for enforcement. So it actually generates the security policy from you from application behavior. And this policy is declared as a YAML file if you want to. Obviously, this allows us to do zero-day countermeasures and basically block things like unknown CVEs and do nifty things like packet capture. If you ever try to do packet capture in Kubernetes, it can be a problematic thing to do, but it's really easy with NewVector. And additionally, it obviously allows layer 7 things like WAF sensors or data loss prevention things. With that, I just wanted to quickly give you an idea about how it actually does that and what's the process of creating that security profile that we spoke about for Zero Trust runtime. With NewVector, it basically starts everything with so-called discover mode. In discover mode, NewVector learns about how things are going inside the cluster. So, for example, you have a map of communications or a graph. And for every new namespace that you have inside the cluster, NewVector builds this graph. And this graph then recorded and available for you to review. And on the next step, we switch NewVector into so-called monitor mode. This is where you typically out of QA cycle and you do some pre-production testing. So what you do in this phase is NewVector stops learning things and it would only alert about things happening outside of the baseline profile. This means that you can identify two things for out of it. So one thing is if your QA process didn't capture something that it should capture, that application behaves in certain edge cases in such a way that it creates additional communication outside. And you didn't do that in test QA phase. So you can enhance your test QA process and you add stuff to the profile, or you can actually figure out, all right, so there is something wrong with the app, or there is a malicious activity going on there, and you can block it and you can identify and perform your incident response. And obviously in alerting phase, you can react to that and basically adjust the profile accordingly. Then the critical phase, once you move it into production, you take that baseline profile that you're happy with and you flip the switch, and everything else that's not part of the profile is denied. So essentially, when you have something that happens with your app, be it say zero-day attack or anything like that, that part of the execution process will be denied because it's not part of the baseline profile. And we'll see it in demonstration just in a second. So obviously, everything that NewVector does is Kubernetes native. So that means that even if you want to create a profile, you can get this profile back as a YAML file, and you can apply it as a CRD. So that means that this profile, as you see on the right, can be just placed in the same Git repo as your app and travel along through your CI/CD pipeline all the way down to production, which is a great way of integrating it into DevSecOps because you don't have a separate security infrastructure to maintain and don't have things like compatibility problem with between security tooling and Kubernetes. This is a really quick rundown of what the tool does and how it does that. And I just want to make sure that we have probably as a final bit here about how heavy it is, because many of you asked me, but if it does so much, it must have place a lot of load on the cluster. So in fact, because of the design and architecture of the tooling, we measured it with one of the hyperscalers, and we found that in probably about more than 1,000 nodes scenario, the scalability of this tool is linear. And at most, the impact you can see on the cluster is probably 2 to 10% latency increase if you're running full DPI, and which is pretty cheap actually for a full DPI tooling. But if you don't do it for every workload that you have, that's probably going to even less than that. So it's pretty effective and also linearly scalable. So it's a demo time. I'm probably give you a couple of minutes to ask any questions if you have any. Otherwise, I'll jump into demo. So let me, yep, just give me a second. Just let me, sorry. So probably the easiest way to demonstrate how we deal with things like zero-day attacks and unknown problems is going to be let's hack something. So this is where we're going to do things that you probably wouldn't like to see in your production environment. But let's say you have a Log4Shell vulnerable application. Obviously, Log4Shell is vulnerability that was pretty serious a couple of years ago, and it's used here for demonstration purposes. I have an application here that represents a Log4Shell vulnerable app, and in Log4Shell vulnerability, a specially formed string to an app can allow attacker to open a reverse shell into container or any system that runs a vulnerable app, that can be a physical machine as well, and obtain root privileges. So here in the demonstration, I'm going to take over a pod and obtain the root privileges. And on the second step, I'm going to use new vector capabilities to prevent this from happening without modifying app at all. So with that, I'm going to show you how it looks like. So this is a vulnerable app, how it looks like. So it's a pretty straightforward username, password, login. So just, yep. And just in case if you're wondering if you do some random passwords, yeah, it doesn't work and we can't crack it. And even if we do something like this is vulnerable string, by the way, and we still try that and it doesn't work. So we need to run an exploit. And what I'm going to do, I'm running an exploit and somewhere you can't see. So I'm pretending I'm a hacker. And I run an exploit, and this is a vulnerable string, as I said. This is my receiver for the reverse shell, which I have here. Just give me a sec, just make sure that we have it here. So this is my netcat that listens to port 9001 and waiting for a connection to happen from the vulnerable pod. So I'm going to click on login here. As you see, something is happening. It's not returning me anything back, but I can see that there is a connection received here. So I actually successfully cracked the pod. Let's verify if it's actually cracked. So first of all, we run ID command. So ID tells us that I'm root now, and I can do things like cat etc os release. Or I can do something like wget and install software inside that pod and perform any lateral moves I want to have. Now, it's obvious that, yeah, this pod is vulnerable. So what can be done about that? Because normally you would wait for your supplier to give you a patch so you can integrate it in your application and basically continue running it. What if it's an open source app and you don't have a patch, or you have a vendor that's a bit tardy and does not produce patches in the way you want it, or with the speed you want it? There are few things that you can do if you don't have things like new vector. You can stop the app, and that means in many cases stopping the business, or you can develop patch yourself, which can be problematic for a lot of commercial companies. There is another way. You can do zero trust runtime. So how zero trust runtime typically looks like? Because it's a profile, and in my new vector environment, I'm going to accept the risk of running self-signed certificates. It actually created as a policy, and the policy that I have in my new vector is called Log4Shell, and it's currently in monitoring mode. So what's useful about this policy, it actually tells you what your application needs in order to run. It actually needs the Java process and needs POST process. That's it. And there are a couple of network rules and file access rules that it creates. So we can also see that because it's in monitoring mode, we should expect that something was happening in the past few minutes that should be reported on. And if we go to security events, we actually see that things like wget or cat or ID are not part of the profile that new vector created for this app. But because it's in monitor mode, remember, it didn't do any action to prevent this, it's just alerted us. So this means that even if you don't have it in protect mode, you can still see attempts of hacking. But the problem is if you don't have it in protect mode, then somebody can still hack things. So what we're going to do today is we're going to change that. We're going to flip this switch. And we switch mode to protect. So that means that I won't be able to execute any of the processes that are not listed here, and won't be able to create any network connections that are not listed here. Remember, this profile created automatically based on what application should be doing. So if I go back to my vulnerable app, and while exploit is still running, I'll click on login, and it now says that my password is invalid, which is quite correct. So, and if we go back to new vector and look into our notification stream, we can actually see that there is a process profile rule violation triggered by new vector, and the action was denied. So this is exactly what happened when you have something like zero-day attack, and you don't know where the attack can come from, what component is vulnerable here, but you can effectively prevent it from happening just because you have such a good baseline profile that actually blocks things from executing if it's not part of what you want app to do, which is a very effective way and very efficient in a way that you don't need to know how the attack look like, because you can actually prevent it from happening through zero trust runtime enforcement. So how would you do it in a normal scenario though? Because here it's all very imperative, right? So we created a profile within the same cluster. We changed the enforcement mode, and we essentially it's all manual. So how you would typically integrate into things such as CI/CD pipeline. So this is where the GitOps operations come into play. Typical GitOps operation requires everything to be declaratively defined. And the security policy in NuVector can be one of those declaratively defined elements. So if I go to my rancher configuration, you can see a couple of clusters running here. The local cluster represents my production cluster, and RK2 represents my development cluster. So in both of these clusters, I have an app that just runs Nginx. And let's look at this app. There is a service here that serves exactly one page that it says it's in a development environment and it's Nginx. If I go to my workloads and try to open a shell, and let's assume that somebody tries to execute a shell in this container, I can easily open it because it's default Nginx binary and a default Nginx container. And if I look how many binaries I actually can execute there, it's 479 binaries. That's quite a bit, right? And if I look at what this application needs to run in order to function, it's actually not 479 binaries. If I go to my deployment and look at process profile rules, I only need 2 binaries to run. So the rest 477 binaries, they actually not required for application to function. That's something to keep in mind. So what if I want to say take this configuration that I really like here, and I really like this profile, but I don't have access to production, and probably in most cases, probably people shouldn't have access to production. I want to take that profile and put this into a Git repo for everyone to review, and then apply it in production, but in different mode, in protect mode, because I already tested it in QA phase. So what you can do here, you typically don't do this in a normal production environment, because what I'm going to do now, I'm going to commit into my prod branch directly. So typically what you would do, you you do a REST API call to new vector, for example, or you click on export policy and download it locally and create a PR against your deployment. But I'm brave enough. I'm just going to commit this directly to my prod branch. I have a CI/CD tooling that has two targets. The one is my development cluster and one is my production cluster. In my case, I use our built-in tool called Fleet, but it can be Argo CD or it can be any other CI/CD tooling if you like those, because it doesn't really matter. So just to quickly show you how it works. It actually has two targets, and it's got, as you see, it's just flashed a light. That means that it detected a change inside the Git repo, and this is Git repo, by the way, where I can see that I got this pretty YAML file with all the security configuration I want. So with that, actually, I think we did that, and we can go back to our production cluster. Say here, and look at the policy that's been applied. Yeah, we can see there is a policy that's been applied. It's marked as CRD. Yeah, the one step I skipped here, I actually had to switch it to enforce mode, but it can be easily fixed. If I go back to new vector dev, I'm going to delete it from my GitHub just to make sure it doesn't have conflict. You probably never do it in production, so for demonstration purposes, it's fine. But normally, you would create a pull request with this change. So what I'm doing here, I'm exporting it in product mode. So that means that when it's applied into production, it's going to flip the product mode switch. So again, so we got it exported. We have it in our repo. So we'll wait for a couple of seconds for it to be applied here. I'm running on my laptop. It actually tells you quite a bit about how effective this tool is, by the way. Oh, there we go. We have that CRT, and you see the P here. That means it's running in product mode, so it won't allow anything outside of this list of processes. How would we test it? That's very simple. We go to our rancher and we go to our production cluster, and we take that workload there. It's called Nginx, working with GitOps. Still, yes, it's called Nginx, I guess. Here. Yep, this is our deployment. And if we try to shell into that, we actually got it killed. And the reason is, you already guessed it, is because new vector enforces the configuration that came through the CRD YAML file. It's got applied automatically, and therefore you won't be able to shell into this container. In fact, you cannot execute any of the binaries that you see in the prompt, because the only two binaries effectively are allowed inside this container. So if we go back to our production new vector and see security events, here we'll see that some of this effectively, yeah, this one, the shell command execution was denied because obviously it doesn't match the profile that is set by the policy. So one of these things can be helpful, and it defines essentially a zero trust environment where you know things that basically should work and everything shouldn't work. What if you want to deal with things like data exfiltration? And these things a bit more trickier to avoid because with things like Optus breach, it was a pretty legitimate REST API endpoint that was breached. But there are other ways you can do through things like WAF sensors or data loss prevention elements that piggyback on the ability of NuVector to see what's happening at layer 7. So, and as an example, I want to show you here is OWASP Juice Shop hack. If you ever learned how to do penetration testing, you're probably aware of OWASP Juice Shop. It's a intentionally built vulnerable app, and that app gives you opportunity to explore how you can hack things. So one of the first steps in OWASP Juice Shop is for you to do is to crack the login screen. The login screen is deliberately designed to be vulnerable to SQL injection. So let's have a look how it looks like. I have Juice Shop running inside my cluster, and actually thinks I'm already solved the login challenge, which is probably a good indication that I have a cookie here. But essentially, SQL injection, a primitive one, looks like this. So you basically have a closing quote, and if input is not filtered, you can put in any random true statement for the comparison to go through. So you click on login, for example, and it would log in. So in case if you have things like NuVector, and you have things like WAP sensor, that's example where I preventing this from happening. My WAP sensor is active, so what it actually senses, and we can see it in the security feed of the events. Somebody actually tried to do SQL injection inside my container. So that means that without even modifying an app or without having a source for it, I can prevent things like SQL injection from happening. And because WAF sensor can actually see that this attack, it actually raises as an alert, it blocks the attack, and it actually gives you a very nice thing for incident response. It actually captures a PCAP in the standard PCAP format that you can load into Wireshark, and you can do your incident response or triage with all the evidence you need about the attack, which is, I think, pretty cool. What if you want to do packet capture without triggering an attack, or you use it for debug purposes? This is one of the features of NuVector, which could be quite useful for debugging purposes. Or inside any container, you can basically click, and if you have enough pods there, we can do things like packet capture, and you can start recording and then download things and load them into Wireshark, for example, for debugging purposes. So this is one of those things that we have just because we sit on the virtual switch rather than in eBPF. So we actually can see these things happening, and with no cost to performance, we can just capture things. If you ever try to do it manually, it's actually quite a bit of pain of need to have something like TCP dump inside a container. And if you don't own the container, it's even more problematic. So on top of that, NuVector is as added benefit, gives you an ability to see network graph with all the communications coming and going. This is an additional to everything you saw about Zero Trust runtime, but it actually quite useful visualization, and also give you a picture about what's happening inside your cluster, especially for people who just want to know what type of communication we create and what type of communications are welcome or not welcome. It also supports things such as Istio, for example, for communications with sidecars and things like that, if that's needed. I don't have in this cluster, as I said, I run it on a laptop, so it could be a bit too heavy for it, but it can be done. Additionally, speaking of things that outside of say Zero Trust runtime, what if you just need to filter out existing things when you want to see vulnerabilities? And these are things that are all displayed on the graph itself, but can be also seen in the report. Probably one of those things, if you see here the red circle here, it actually has some number of high vulnerabilities. So that it's a way for NuVector to quickly give you an overview how vulnerable things are. For example, our SUSE shipped containers, they typically have very minimal number of vulnerabilities. That's why, for example, this one is yellow. So if you click on details, we have only, say, 10 vulnerabilities that probably of medium type. Because it comes from our trusted registry and we look after this container, versus say something like that is deliberately vulnerable, such as log4shell exploit. That's good. So 8 critical vulnerabilities, some of them with CVSS score 10, for example, but that's okay. We know about them. But what's actually worrying is that one is Nginx deployment, because Nginx deployment here comes from the standard standard distribution of Nginx from Docker Hub. So it's basically if you use upstream Nginx, that's what you get. So, and you get by default from the latest version, you get 41 critical vulnerabilities and 73 like less important vulnerabilities. So, but why so? So typically it's not an Nginx that is a problem, because if you look at the scores and where the highest score vulnerabilities are coming from, they typically come from system components. And these system components is defined by the base image that you use. And here's what I want to stress here. Probably as much as important for you to have a tool that deals with zero-day attacks and stuff like that. Probably the best thing you can do if you're just starting your Kubernetes security journey, you filter out the existing vulnerabilities, and a lot of these vulnerabilities come from base images. So I want to give you another example that I have in my environment. It's in different NuVector. This is development cluster. So I have 2 WordPress deployments, and they have MySQL coming from 2 different sources. So the first one is coming from our source called application collection, and it's based on SUSE base container images. Base container images is free for everyone to use and can be freely redistributed with any limitation. Because we look after these base container images, we strive to make them to have as minimum number of vulnerabilities as possible. This is fairly old image, by the way, but it still only has like 3 critical and 2 less important vulnerabilities. Versus if you take the upstream image, for example, it's this here, you will have 12 and 36, for example. Some of these containers can vary drastically. If you take one from upstream and you take one from, say, more trusted source of base container images, you will see that the number of vulnerabilities is drastically different. This is why a choice, or when it comes to secure supply chain, about base container image is fairly important. So how would you say, for example, take standard vulnerability management in NuVector? It's also can be done through the same console, although we have a standalone scanner as well. So for example, you can take our scanner, integrate it with your CI/CD pipeline, and fail builds if, say, number of high priority CVEs, high importance CVEs exceeds certain numbers or exceeds certain time to react. So if we take one of our applications, say Nginx, that lives inside GitOps namespace, Nginx is actually pretty good. Typically, it's a pretty good container image. So but still, because of the base container image that they use is fairly old version of Ubuntu, it actually has a fair bit of high priority CVEs inside them, because that's just the way it is. Some base container images are targeted to reduce that number, and some of them they just produce the standard operating system versions. For example, this one doesn't have a fixed version at all. That means if you have that vulnerability with this container image, you have no way of escaping that vulnerability, except for if you have something like zero trust runtime from new vector. In many cases, we don't like that, because what we think is also important for security scanners to do is to do something like fixable vulnerabilities. Fixable vulnerabilities are important because it's something that your developers or yourselves can act upon. And when you do the shift left approach, then everybody talks about that. Make sure that you deal with security during the build phase, during the initial phase. This is where it's actually quite important to stress that in case of, say, Nginx, it doesn't have fixable vulnerabilities, the ones that you can fix yourself, which is pretty cool. It's actually what we want to see from a container image. Still, had the, say, Nginx project selected a base container image from SUSE, they probably likely had like less than 5 vulnerabilities altogether. Obviously, this number varies, but definitely not 70 that we see today, and they all come from base container image, and you can't fix them because they're not fixable. That's something that I want you to kind of keep in mind when you thinking of Kubernetes security at large scale. So other than that, obviously, we have a tooling that helps you with compliance. We have a variety of compliance profiles that you can use for some financial sector. Something like PCI DSS compliance can be fairly important. For general computing, things like Docker SUSE benchmark configuration of baseline security profile can be also useful as just to have as a benchmark and making sure that you don't have insecure configuration entering the cluster. As additional component, we have things such as admission controller. All of this information around compliance and vulnerability management can be fed into admission controller. And in admission control, we can define certain things in that take into account security posture of deployment that you try to run inside your Kubernetes cluster. For example, if you have security vulnerabilities, but they have been scanned and approved by somebody, they can enter the cluster. Or if something that you know that's coming from a certain registry that shouldn't have any vulnerabilities there, you can prevent things from entering the cluster. So it's got a fair bit of criteria that you can use, including naming, including labels, including status of security scanning, image type, source, destination, and things like security configuration of the pod itself. So, for example, you can restrict things such as privileged pods and things like that. So there is a fair bit of criteria here. I don't want to go through all of them, but they are all available, and it's a part of dealing with known vulnerabilities and part of dealing with known problems. And obviously for unknown things, you can always use NuVector Zero Trust Runtime to help with that. So as a probably just to wrap it up and open the floor, I just want to give you an idea that NuVector is an open source project. So you go to github.com/NuVector, and you can grab yourself a copy of NuVector under NuVector repo. So all of this is basically open source project that you can use to enhance your security posture. You can use it in a variety of Kubernetes environments. It can be any of the managed Kubernetes environments. It can be EKS, AKS, GKE. It can be things like OpenShift if you want. It can be our own Rancher Kubernetes distributions, or it can be any literally CNCF certified ones. You can use certain components and things like Docker even. For example, if you just want to run a security scanner, it's all supported. You can also use it in some obscure Kubernetes distributions like D2IQ or in others that probably don't have a lot of use today, but there are a fair bit of those still around, still need protection. The only, I think, important exception to that is it has to be Kubernetes compatible type of distribution. So for example, if you're running something like HashiCorp Nomad, that's probably not a good candidate for NuVector. With that, I think we have a few minutes for any questions that we have outstanding. Please let me know if there are any. So I'm just reading a few of the questions in the chat, and one of those is how we make sure that we don't have false positive things inside NuVector. So it all comes down to a very simple thing. You run your QA cycle for your app, and you make sure that whatever application should be doing is actually recorded correctly. So the application behavior is fairly reflected by the security profile. That basically your insurance against false positives, things like that. Another thing is, I think the one is that being addressed correctly. Can it be integrated with SIM tools? It is absolutely great question because we don't like it being storage for your security information or additional security console because your SOC already have too many of them. So absolutely everything you see in NuVector can be then channeled into SIM, where it can be correlated and analyzed and dealt with by your SOC through SOAR or any other automated tooling that you have. So we have certain integrations with Splunk for build phase as well. Well, with that, if no more questions, I'd like to thank everyone for attending and for all those questions that you asked. And yeah, I'm happy to run a follow-up session if you like to do one. And let me know if you're tried NuVector, interested in it, and have any more questions to us. We're happy to address them.